Good afternoon, everyone. We are talking about MySQL Sandbox, one program to install multiple MySQL instances in the same host. It works on every Linux system, every Unix system. So it works on Linux, Mac OS X, Solaris, OpenSolaris, FreeBSD, and perhaps many more. So what is it? You know, if you have one MySQL server and you want to test something else on the same box, you can follow the manual and suffer and make mistakes, or you can use MySQL Sandbox and do that in a couple of seconds. So the way Sandbox works is like this. You send command make sandbox and the name of MySQL tarball. Time loading 5 seconds and 600 milliseconds. So it's quite quick. How does it work? Sandboxes, MSB, use, and here you have your MySQL server ready. This, by the way, is MySQL 5130 GA. It's not the one that it's the same that you will get in a couple of days from MySQL download. You can do whatever you want here, and you can have several servers of different versions. For instance, we can do install MySQL Sandbox, make Sandbox 5067. Also this one, and we can use it in the same way. They don't interfere to each other. 067. Here it is. Now, you want to test some replication? Easy. Let's do time. So the command is almost the same. Instead of make sandbox, we say make replication sandbox. Installing the master. Slave 1, slave 2, initializing, total time 16 seconds. I don't know if you can do better. The same thing you can do for another version. 5067. Master, slave 1, slave 2, initialize. The 50 is much faster, as you can see, less than 5 seconds. How does it work in sandboxes? You have one directory for each single sandbox that you have installed. So we have MSB 5130, MSB 5067, and then we have our sandbox for replication. Instead of our sandbox 5130, you have M for master. Look at the prompt on the bottom line, it tells you that it's a master. Use test, create table T1, and then we use the second one, slave. Use test, show tables, and the table is here. So replication works. You can also do something more ambitious. Make replication sandbox minus minus circular equal 4. It will create a circular replication with 4 nodes in 7 seconds. That's it.
Great.
It's public. It's here in Launchpad, MySQL Sandbox.
All right, Jeff Sachs. Latency is everything. I'm going to talk, I could sort of describe this as a generalized problem, because it is a generalized problem in application design, in client-server architectures, in iSCSI disks and fiber channel over IP. There are many places where latency is everything. But I will give a specific example from one of my previous employers. This company went from an old model of terminals on desks, thin text-only terminals attached to shell sessions in Unix minicomputer, to Windows GUI fat applications talking to a centralized MySQL server. Okay? And they made their application richer and put all kinds of business logic into the application and made it easier to use, and then the SQL Server backend was fast and everybody was happy. And then the developers did what Microsoft said you should do, which is N-tier business logic in a .NET application server, right? You should abstract all of your business logic into .NET web services. That's so superior. So the developers did the right thing. They put all the application into middleware DLL components on an application server, and then they had the client running a slightly thinner fat app make calls to the .NET web services, which would then do SQL calls to the SQL server, and then do the correct thing to the results, and then deliver them back to the client. And they released this, and everyone was happy, except for the remote branch office on the other end of a thin T1 pipe far away. It's not all that far away, and it wasn't all that thin a T1 pipe. If they wanted to do regular things like file transfers and email, it actually worked fairly well. But they discovered that the salespeople at the other end of this pipe were at a distinct sales advantage, because while they were talking to a customer on the phone and they typed things on the computer, their computers reacted a lot more slowly than the people at the main office. And I helped to figure out why this was. They didn't complain about it for a long time, but after a while they got tired of their commission checks being smaller. So they complained about it, and I helped debug it by watching the data streams, and it turns out that the application used authenticated HTTP with Windows authentication to prove that you at the computer were a valid user of this .NET web service, and also serialized things in SOAP, a SOAP data call. So basically, to make what used to be a single SQL call, to make a single SQL round trip, it now became, hi, I'd like to do this web service. Well, here's the SOAP's, hi, I'd like to start this web service. Prove that you're you. I accept NTLM authentication. My name is Jeff Sachs. Prove that you have Jeff Sachs's password. Here's your challenge. Here's my response. Okay, you're Jeff Sachs. I would like the SOAP schema that I need to use for this database call. Here's the schema. Now do my call. Tiny bit of response. Okay, now here's your answer. So each one of those is down like a 40 millisecond or so T1 pipe. And this was really, really bad. It doesn't sound like very much, and if you run it all on your developer laptop, it's really fast. And if you all run it all in the same data center, it's really fast. But if you move the client to the other end of anything with any tiny bit of latency, then that latency is magnified, multiplied by the number of round trips it takes. And this was really terrible. So I helped them to figure out what the problem was, and they kind of addressed it in a couple of stages. One was they were actually doing all of this call, all of that machination, they were actually doing per item in the shopping cart. And so when you wanted to load up a shopping cart, it has to do all of that, and then the next line do all of that again. So that was really awful. So we thank you. We got it to at least do it all in one bundle over that, and then later on they put, I guess they put a cluster of 2 .NET app servers at the other end of the pipe, so that all of that back and forth was actually between workstations in the same data center, and then the only thing coming back up the pipe was the SQL calls that used to come directly from the workstations when the business logic was in the fat app. So I don't personally see the strong appeal of moving the business logic to the .NET middleware server, but it helps some development processes. So anyway,
for you.
What's that?
It was a job for you.
Yeah, I helped to fix it.
I just worked on a project where a client was in one government agency, needed to access data on from another government agency that they had implemented using SOAP. And
Yes.
we had to, using our search criteria to get back, we could get an array of records with summary information, but had to fetch each detail record individually.
Right.
So if you wanted like a month's worth of data, it might take hours.
And all you have to do is change it to a query
Yeah.
that produces the whole result set, and then you're limited by bandwidth, not by latency. Yes. All right. Thank you.
Thanks, Ben.
Oh, okay. Distributed configuration management systems. Everybody here does software development. You've got some kind of version control system, and the big trendy thing now is distributed. It used to be everything was centralized. You had CVS, you had a central repository, everything goes here. Now everybody wants to do it distributed, where everybody has their own private repository, and you push and pull between the various repositories. There are advantages and disadvantages to this, but it's really, really trendy, and so everybody wants to do the distributed version. And so the traditional ones are like CVS's version, and then the distributed ones are like BitKeeper, Git, Mercurial, and Bazaar. Everybody with me so far? Okay, well, you think about these BitKeeper, Git, Mercurial, and Bazaar, they all have a database. It's really a collection of files in the file system. I mean, it's not a relational database, it's not an SQL database, but it is a database. And so the question is, can we do this actually with an SQL database? And in fact, it's already been done. There's this thing called Monotone, and it was the original open source distributed version control system, as far as I'm aware. I'm not aware of any open source that came before it. And it has an SQL database engine on the back end. A Monotone is a self-contained standalone binary, so that you can just download it from their website, put it on your system, and start using it right away. It's really easy to use. It's self-hosting. It's got everything built in. Linus Torvalds was actually studying Monotone, and that's what he used it sort of as a basis to write Git. And he grabbed a version of Monotone that had a bug in it, and it was just glacially slow. And they fixed the bug a week after he looked at it, but he to this day thinks that Monotone is still glacially slow. But it's really, really very quick, and it's a lot easier to use than Git. Now the advantages of using an SQL database in something like this is, one, you get atomic check-ins for free. And not only atomic just when you're checking in, but if you're in the middle of a check-in and you lose power, you get a system crash, it's still atomic. You've got a single file repository, you've got an open file format, you've got all sorts of complex relationships that you can put in your repository, and you've got a built-in query language. So the thing is with these things now, we want additional information. So there's this new system out called Fossil. It has everything that Monotone has, self-contained SQL database engine, self-hosting, but it also adds distributed bug tracking. So not only you've got distributed version control, but you also have your bug tracking can be distributed and operate on a disconnected basis, and you have distributed wiki. It's got a built-in web server. It's basically SourceForge in a box, but distributed SourceForge. You don't have to be connected to the server in order to make this to happen. You can go and download it right here and start running it, and when you get it in your system, you can either clone an existing repository and make your own copy right there, or you can start your new one, and then you just type this command, Fossil UI, and it immediately starts a little mini web server, and it also pops up your web browser and makes it point to that thing so that you can start working with it. Or if you want like a persistent server, if you don't want to write, you can, with a 2-line CGI script or an entry in inetd, you can make your server persistent. And when you do this, you immediately pop into a page which gives you, this is a wiki which contains documentation. This is the self-hosting fossil repository, and it's got documentation on how it works, and you've got like a timeline of everything that's been happening in your repository, and you've got details on a particular check-in, and you can look at the diffs for that check-in, you can enter new tickets, you can look at existing tickets, you can look at all the files, you can look at the history of a particular file, you can do diffs on that file, you can do annotated diffs on the file, you can get status about the whole repository, etc., etc. There's a bazillion screens. You can dig way down into your repository, see what's been going on. This gives you situational awareness on your project. And really, you can't do this. This is made feasible by the fact that you're using SQL. 2 minutes left. Thank you. It's made feasible by the fact that you're using SQL. Situational awareness of your project. I cannot overemphasize the importance of maintaining situational awareness. So these are the places that you can get these two configuration management systems. Full disclosure, I wrote the second one and I wrote the database that goes in them both. Questions?
Who uses Faucet?
Faucet, there's about 24 different projects that I'm aware of that are using it. Self-hosting, SQLite uses it for documentation. There's a few around the web. It's relatively new. It's still under development. We could use some help, but it's very stable and people are using it. Monotone is used all over the place. Other questions? If not, we'll go to the next talk. I yield the remainder of my time to the
Hello, everybody. I decided to volunteer to do a talk on Memcache functions for MySQL. These are a group of user-defined functions that allow you to interact with, I don't know how many slides, sorry, to interact with MySQL, with Memcache from MySQL. These functions are really easy to use. As you'll observe in this window, I already have an instance of Memcache running. If I go in here into, the first one of these I would run is select memc set servers. And in this instance, I have one running on.
You want servers.
What's that? Oh, yeah.
V.
Yes, and I need to learn to spell better.
Someone put automatic spell checking into MySQL client, please.
There we go, memc server set. So, and in this case, I've set it to the port that Memcached is running on, and 127.0.0.1. So that's set. So now I can do memc set. And now I can do memc get. Now this is nice because you can do all of your interactions with Memcache from within MySQL. And there are some other wonderful things you can do, such as use triggers and stored procedures to kind of glue it all together so that you don't even have to think about how your data is getting put in there. There are many other functions. If we look at SQL func, oh. So these are all the functions that are available. There's add, there's set, there's get, and each one of these does essentially what it says it does. And you can do the last one we did, for instance, select memc prepend. Oops. Sorry, I'm a little sloppy right now. So now it prepends it, and a pen would work the same way. There's a status one, select memc get stats. Sorry, I need.
So obviously, Patrick, you can access the Memcache stuff from normal native calls.
Yes.
Just layering from SQL.
Yes, it does, and I'll show you some of the nice tricks you can do. Here's within this distribution, I created this thing called Trigger Fun, and essentially, you'll see, the example I have here is a table full of URLs, and then you can set it memc, set URL sequence, you set a 0, and then you set your delimiter, you create your trigger. And then with that trigger there, what happens is each time you insert one of these, it automatically gets put into Memcache, and then you pull it out by the name of the table and the primary key that it was inserted with. So that shows you how you can use this, and we can actually run this. So you can see how it's working. I mean, this is some of the cool things you can do with this. It's really easy to install. All the install instructions are with these UDFs. You basically build it and make sure you got to have these. Use libmemcache. One of the benefits of this is that it uses libmemcache, which is a really fast client library to memcached, as opposed to using Perl interface to memcache. So it's pretty fast, and it gives you full functionality to talk to memcache. I know I'm saying the same thing over and over again. Are there any questions you guys have? No?
Did you develop this for a specific project or use?
It was kind of a proof of concept. I was talking to Brian one day, and I said, it'd be kind of neat to have to be able to write some UDFs that talk to memcache, because then you could do a lot of this stuff from within the database. You wouldn't have to write a bunch of Perl glue inside of your web application to set it in the database and then set it in Memcache and vice versa. So I started working on this, and little by little I added some functions to it, and people seem to start using it. And there's quite a few people using it now. It's a pretty useful thing. I think Facebook's using it. Some company in India that he needs me to get this working for Drizzle is using it and wants to use it for Drizzle. So it basically helps you glue things together in the database.
Is this the beginning of MySQL turning into PHP kind of namespace?
I don't know. I'm a pro guy. So.
Yeah.
You got any performance stuff, Patrick? Any performance metrics?
No, I don't really. I have this comes with a suite of tests that I wrote. If you go into the test directory, there are all these different tests that it runs. Essentially, what you do to run the tests is you do MySQL-su root. It's not as easy as like running the test suite in MySQL. Test SQL. Oh, is it?
Yes.
Okay. Anyhow, if you guys should have any questions, feel free to ask.
So I'm Bradley Kuzmal, and I'm a research scientist at MIT. I'm on leave working at Tokutech. My research at MIT led me to some algorithms for maintaining indexed data faster, and so then I started looking around for benchmarks that would measure how well you could index data. And so we developed a benchmark that measures how fast insertions go. And we developed a challenge to insert 1 billion rows into MySQL and its indexed data, and to see who can do it fastest, because I wanted to, maybe I don't know how to use MySQL right. And we've got a very generous prize for anybody who wins this. Okay, basically the existing benchmarks don't test index insertions very well. For example, TPCH essentially doesn't really measure the insertion time at all. The star schema benchmark also is basically a bulk load. Sysbench seems to be primarily used to measure sort of in-memory performance of multi-threading. So we developed the index insertion benchmark, and it's a simple test. It's open source, it's GPL'd, and you can download it from our website, tokutech.com/contest.php, where you can also, I think you can get this slideshow. It's a very simple schema.
Stop that.
There's some rows. Some of them, there's 1, 2, 3 indexes that are fairly interesting indexes. They essentially look like random data, those indexes do. There's 1 billion of rows in the main fact, in the main table, and these transaction IDs, which are auto-incremented, there's 1 million of them. And then these other things sort of have the kind of distribution that you find in these benchmarks. where you have a certain number of customers and a certain number of products and timestamps and so forth. It's written in MySQL++, and basically the loop is a billion times generate a random record, insert it in the table, and we commit once every 1,000 rows because we're not trying to measure the time to do a commit, we're trying to measure the insertion time. And it prints the elapsed time once every million rows.
And do you do it one by one instance?
Pardon?
One by one, or is multiple value for all 1,000?
It's one by one, but if you want to, if you think you can do it better by doing, I think that's fair game to change that. So for InnoDB, so each of these spots represents 1 million rows, and the vertical axis is how many rows per second we were getting. So at the beginning, we're getting 8,000 per second. The horizontal axis is how many rows were inserted. So here's 400 million rows, so 400 dots have appeared by this. And you can sort of see it falling off the cliff as the database gets out of main memory. And InnoDB does pretty well. It kind of ends up out here at 400 rows per second on this machine. It took 20 days to insert that data. For MyISAM, it took 100, well, we got this far and ran out of time because it was only doing 93 rows per second. It looks like it's going to take 4 months to finish that, so I'll let you know. If you don't maintain the indexes in MyISAM, it runs really fast. This is how, so this is really all about the index maintenance. Although you may gain something by doing multiple rows per insertion, the problem is not really so much there. Maybe you could get from 10,000 up to higher numbers, but this curve isn't going to get any better, I predict. We'll see. So this was a fairly inexpensive machine. It's a dual socket quad-core machine with 16 gigs of memory and 8 disk drives, 10,000 RPM drives. It's running CentOS and MySQL. And so the ground rules for the contest is you got to have hardware that's sort of like that, memory that's sort of software. Use one of these storage, use some storage engine. You have to actually maintain the indexes because sort of if you insert all the data and then create the indexes in bulk, that's a different kind of a problem. And so that's
So how large a bulk can be?
Well.
There was like a bulk insert tree optimization.
So
can insert by million or 10 million rows efficient?
well, 10 million would be too much. So I would say that if it's less than one, if it's more than a second old, it's getting kind of uninteresting.
I mean, it's good if you can define the rules right here. But, for example,
Once per second, you have to,
Good. Be specific. That's always cool.
Okay, so we'll fix that up. The due date is New Year's Eve. There's an email, contest@tokutech.com, and I'd like to see.
Engine, right?
Sure.
Black hole. You said 5.1.
Well, it's got to maintain an index, and Black Hole doesn't. So.
Oh, yes. And then also to understand here is when you're speaking about insertion, that's going to be in sequence. You cannot pick the order in which you insert those big rows.
Well, if you change the order, then you're going to have troubles on the other tables. But
yeah, I mean, again, that's just a question of rules.
the rules are
for
this
example,
is the order.
InnoDB likes inserting primary key order, right?
This is being inserted in primary. This is being inserted in primary. It does do it in primary key order. Right? It's an auto-increment primary order.
Sure.
Okay. I'm not sure how many people here actually know anything about blob streaming engine or anything, or heard of it before. That the whole idea of it is to get around a lot of the blob problems that we have with MySQL, which is mainly the problem of buffering blobs. And when you start sending blob data through MySQL, it basically bogs everything else down because you've got these massive amounts of data and it consumes massive amounts of memory. And it's generally not really designed for that. So what we've come up with is the blob streaming engine, which is a pluggable engine. And unlike other engines, though, it kind of works as a side engine which just handles blob data, and it takes the processing the blob data away from MySQL. And what you have is if you're using the blob streaming engine, you'd be sending the blob data to the engine itself, and the engine would return to you a URL, and that would be what was inserted into the database. And the database, the engine that you're using in the database would understand this URL, and it would be able to communicate with the blob streaming engine and say, okay, I've got a reference to this blob, and it would keep track of it. And so that also when you delete all your references in the database, then your blob should also be deleted, so that you don't have this data sort of lying around indefinitely and you don't have to try to maintain it separately. But the big advantage really is that when you go to select the data and select the blob data back out, through MySQL all you're doing is passing up this relatively small URL, and the actual blob data is coming from the engine. And the engine actually streams the data back up to you, so you don't actually have to buffer it on your client side either. It can catch the data and pass it up in chunks if you're doing it over the web, or write it to a file or do whatever you want with it. So it takes a lot of the problems with blobs away from MySQL. Right now, originally it was designed to work with PBXT. PBXT supports this internally, so that if you insert a blob URL into a large blob column in the PBXT table, it will automatically do all this for you. Recently, I've changed the engine a bit, and so that I've introduced some UDFs and some triggers, so that it'll also work with MyISM or any other database now. If you just install these triggers, you insert the data into these columns, it'll notify the blob streaming engine of it, and it works pretty much the same. It's probably not quite as efficient as being internally processed, but at least it allows you to use this with a MyISM table or an ODB or whatever you have. So right now the blobs are being stored in repositories by the engine locally on the file system, and they're all basically, the repository is one large file, and the blob is sort of the blob URL will have an offset into the file, and so that's how it locates the data from there. What I plan to do in the future is change that, and so allow you to specify how you want the data stored, because sometimes it is actually nice to have the data, your blobs, actually in physical files somewhere. And also a possibility, which is probably one of the first things I'd like to do, is to actually allow you to store the blob somewhere else, such as in Amazon S3 storage, completely off your file system entirely. In which case, what the blob streaming engine could do is actually pass you up the URL to the S3 storage, and so when you want to fetch your blob data, you're not even accessing the same machine as your database server is on, but it's actually going on to your Amazon storage to actually fetch your blob data. So that's kind of what the future is holding. I was just talking to Brian Aker about building this into Drizzle, in which case probably we'll have more direct support in there for it, with be another means of dealing with blob data. So that's kind of the real fast, dirty explanation of this. I would have liked to have had more slides. I didn't actually have any idea I'd be doing this until yesterday, so we're kind of stuck with this. What we got here, the documentation is available on blobstreaming.org, and that this is all on Launchpad and can be downloaded. And there's a couple of, currently there's a beta version available there, which works with MyISM or any other engine. It of course also works probably best with PBXT, because then you don't have to set up any other things with it. There's also, it's not just thrown on here, there's an API that goes with this, which is C API, so that your client side doesn't have to necessarily know anything particularly about this. And in a very short time, we'll have a PHP API that goes along with it also. So, 5 seconds left. Okay, so that's it.
Just going back to some requirements sometimes you have with whether it's regulatory compliance, Sarbanes-Oxley, HIPAA, one of the ISO 2700 series type requirements that may be put on you. The fact that you must store your audit trail, any type of log, in an indelible format that can't be altered after the fact. And perhaps conventionally you might have done it with syslog or something like that. It said file system permissions, and also many Linux file systems or other Unix file systems, an append-only attribute on the file to make it append-only. But if you want the flexibility of using a SQL database, you know, what's some of the ways that you can do that? So we kind of had this conversation at lunch, and this is kind of my first take on how you might accomplish that. Syslog-D, of course, it's widespread. It is used a lot of times after the fact. If there's an intrusion, to go back and work the forensics out of what happened, who's responsible, that type of thing. And to apply this to a SQL database, obviously, just simple replication is not going to work because you're going to replicate any bad stuff downstream as well. And also, without modifying the database engine or without modifying maybe the application, if you've got this, say if you're in a publicly traded company and you just have this requirement thrown upon you without doing a bunch of recoding, what would be the possibilities that you'd have to, you know, to bolt on a versioning type system or something that is basically becomes an append-only or write-only type system. First take on this would be either to use, I suppose you could use Logic Volume Manager and snapshots, things like that, or a versioning or copy on write file system, just some of the more popular open source ones, ZFS, ext3, copy on write, again, LVM, and some of the better file system that's up and coming. Once you've done that, you'll have several different snapshots of both, whether it's your binary logs or if you're doing dumps every so often, periodically you can run diffs upon. The next question becomes, how do you protect those? Because the single point of attack obviously would be a log server. And if you've moved away from something that the kernel is going to strictly enforce access to with the append-only mode, how can you further restrict that? And my first thought would be to use some of the facilities that are provided, whether it's a Linux capability bounding set or security enhanced Linux, to further restrict even what the root user can do to reset any of the either file attribute changes or just simply to roll back old versions of the file system. So just very quickly through these ideas together, and there's probably 1,000 other ways to do it, but it's just some thoughts. Questions? 2 minutes for someone else. Yeah.
What about using MySQL archive tables on inserts, but not SOS? User updates, do a chatter now.
In the past 45 minutes, that wasn't, had not thought of that, but again, there's many ways that you could accomplish the same thing, but just going from the lowest level, having the kernel enforce a lot of the permissions rather than the application layer, that's kind of one of the first concepts that came up. And two, the original topic, the F-SQL, Google it, it's still a maintained project. Last release, I believe, was Halloween of this year, so you can also do SQL queries against flat files.
First thing, lib eat my data. Who uses fsync? Yeah, everyone else failed. So fsync, the idea is to actually write data to disk unless you're on OS 10 because Apple hates you and your data. especially your data, depending on if your hard disk is internal or external or some other bullshit. So on anything sensible, fsync actually writes stuff to disk. The problem is this is really slow. So if you're running a test suite, you don't want to actually wait for rotational media, because that just means you're sitting there going, make test is taking a long time, and you hear the disk going click, 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 and it's really annoying. So libmyData is a little LD preload library I wrote that wraps fsync to always return success immediately. It wraps fdatasync to always return success. So it's like macOS 10 emulation. And it also wraps like open to take out the osync or other such flags. And it means it just can shave like minutes or hours off a bunch of your tests because you're not actually writing safely to disk. So for the MySQL test run suite, this can shave easily, like off a 2-minute test can easily shave 30 seconds off it and stuff like that. For small things, you can do a lot more. So if you actually have some test suite that even goes to a database, run the database with like LD preload libmyData.so and don't store your real data in there, that your test will be faster. So it's pretty cool that way. I think I branched out to Launchpad, otherwise just Google libmyData. libmalloc fail is another shared library that accepts a few environment variables and parameters and then randomly returns null from malloc according to your rules. And you'll be interested to know that everything pretty much explodes when you do this. Nobody writes code that handles memory allocation failures. Except well, the other thing is I actually found a libc bug in there. So if you actually use the internationalization stuff in libc, it will explode. If you always fail malloc, it will explode before you actually get to main. So there's a bug that needs to be fixed somewhere. But libmalloc fail is kind of useful if you're doing that. The other next step I want to do with that is with a few other flags on it. So for each malloc fork, one of them succeeds, one of them fails. And then you need some extra code to quit gracefully on the fail and sometimes success there. But this is what the NetFilter guys do. And it's like, hey, that's really cool. And then, of course, you realize that with anything that's not just doing with network packets, as it's something that's using with data on disk, you're probably going to have to clone what data's on disk because you could do separate things in each one. But it does enable highly parallel testing as well, which is nice. The next thing, what was I going to talk about? CCAN. So who heard of CPAN? Comprehensive Perl Archive Network, right? Crap loads of 12 modules, do all sorts of stuff. Well, of course, we know the one true programming language is C. All other languages are inferior and wrong. Except perhaps Lisp. No way. But, you know, we're mortal, so programming C. Mainly because if the C book falls on your head, you'll go, oh, the book hit my head, that's annoying. If the C++ book fell on your head, you'd be dead and wouldn't be able to make any comment. So, since humans can understand the language, C is much better. So CCAN is the idea is to create a comprehensive C archive network where it's just like a whole bunch of different modules programming in C for various useful things. And it's actually now up on the web with the website that like isn't just a placeholder, which is ccan.oslabs.org. Otherwise, we just Google for like comprehensive C archive network, then you should be able to find it as well. So it's a bizarrely multiple modules there, including some real useful things, things like simple linked list thing like Linux kernel style, which is actually quite efficient. There is align of to determine alignments of types, like containers of, so you can upcast, so if you have a struct inside a struct, upcast to the other one. Like hash functions, like all this stuff you should never have to write again, which is not part of any real standard library, a bunch of nice little utilities there, including some tools to like simply have namespaces, so this would be CCAN something instead of other things in case of conflict with any existing names. And of course talop, which is like the one true memory allocator, hierarchical memory allocator, really cool. Ever want destructors in C? Well, this lets you do it, which is kind of cool. That was all I was really going to talk about. Drizzle is awesome and watch out. Cool stuff. My code works really well. Thanks.
So what do I define as monitoring and graphing, just so people know? So it's something that's web related, it can record historical information, it provides a graphical interface for results, and it's extendable, which means you can add to it. Having been a consultant for several years at MySQL, there are many organisations that did zero monitoring. So I'm curious, how many people here have no database monitoring in place? And doesn't have to be MySQL, anybody, I think. So you do no MySQL monitoring, or no system monitoring. It's like
email from users.
it's like well, the definition of that is
I look at the machine and it has blinky lights. Is that
the definition of no monitoring is that the users will tell us when the site's down. Okay, and you may laugh, but this is what people do. So I really want to know what people do, because I actually have 2 questions about that. So can people give me an indication of what they actually use for database level monitoring? And those people who are not MySQL, please let me know what you use so I can get a picture as well. So this is a few that I know of. So who uses Nagios/Cacti? Okay, 10 people. What about MySQL Enterprise Monitor? Okay, well you shouldn't be here because this is a gig sort of session, not a sales session. Hyperic. Oh, this is Hyperic. Okay, that's funny. Ganglia. Munin. All right, Munin guys. Monyog, which I didn't know had a monitoring tool, but no one uses that. I doubt anyone's going to be using ScienceLogic TM7. No. Other. What other stuff do you use? Monolith.
I know some people using Xenos.
Okay. Anything else? That's it. So only half of you polled, and only then 5 of you said you do monitoring. So in between, there's a whole pile of stuff. You don't really do anything. I guess one of the questions that I have is that when I was doing the consulting, you go onto the site, you don't really have time to help set up monitoring. It's like, what do you have in place? One of the things that bugs me is that there needs to be a standard. So I'm curious to know if there's actually any support from the community as to whether there was something that we specifically chose. And it might be, for example, ironically, Baron is going to be talking about Cacti later. Is there a move to sort of say, okay, well, let's just as a MySQL community, and everybody else community, choose one, e.g. Cacti, and we will focus on bending the rules of that to support our needs. So does anyone have any feedback or interest in seeing if there is a common project for monitoring? Just so that the community can contribute monitoring alerts and records so that we can all benefit from each other rather than all working in isolation. No one really cares about monitoring. Patrick?
I think that's a great idea because when you're first setting up a whole system, looking at doing monitoring.
Exactly. I mean, I'm finding more startup companies now, and it's sort of like, okay, well, what do you have in place? And they sort of go, well, what's your recommendation? And I'm like, I wish I would sort of say, okay, well, use Cacti plus all of these, Baron, templates plus all the other things, and then there's just the support channel we can talk about, as opposed to, here are 10 products, pick one. Because right now there seems to be different people using different things. So I'm curious as to whether, if people in the community got behind something and said, we're going to work on this, would people help to contribute to it and make it useful?
Automating Nagios install. That's a little bit of a learning curve. I mean, once you know it, it makes a lot of sense.
Sure. So there doesn't seem to be much noise as to whether people are really interested. So obviously you guys don't care when you want to sort of like try and find something that happened last week and you don't know what's going on. Interesting. Wow, I'm disappointed. Somebody else's bad. Yeah. Well, so on a site-related issue, since I actually had 6 minutes, I thought I would have 90 seconds. For many years, I've actually wanted to know what's going on more historically with different versions of MySQL. So I actually created this project, which doesn't have much other than like a plan in place. And it was actually designed, this is just the front page, it was actually designed to sort of like effectively be like an anonymous phone home for MySQL instances. Because I'm always curious to know who's using it, what version are they using, what type of statistics, and in theory, what type of graphing and monitoring are coming out of it, even in terms of like, how long has the server been up, or what type of throughput you're actually getting. So I was planning on in Q1 next year to just work on a project to see whether there's any interest in people actually wanting to provide anonymous statistics so that we can just see what's actually being used in the world of MySQL. And I did also note that I was thinking of the other guys, Postgres and other database products. So I don't know if anybody here is actually interested in doing that, but part of it is twofold. One is to just get some information on what's actually being used, because there are people out there that like using 4.0, for example, and it's really quite interesting to know this. How long the server's been up, what type of throughput they're getting, whether we can actually also, with the very limited level of instrumentation that MySQL has, and Peter was talking about, and Vadim were talking this morning about improving instrumentation. Can we actually draw any heuristics from a larger set of data in terms of simpler settings, and my time is up, simpler MySQL settings that could help in like tuning systems in some basic way for when people have no DBA. So part of it is actually gathering information to do some more data analysis, but then potentially some advisory services or even some teaching for beginner cases. Here's some sample examples. So I'm going to be looking at what sort of least monitoring we can do, and then we can go in from there.
You want to plug in? Or?
Yeah, I'm gonna plug in because I have it down. Ooh, and I've got 2 screens. All right, everybody. The second challenge is figure out whether I can get LVM working. All right, big. Okay. So I borrowed a flash drive from Ronald and destroyed it to show that you can put LVM on pretty much anything. Okay, and it's plugged in here. It's as dev SDB, shows up as a SCSI disk. LVM is really interesting. It fails in fun ways when you're not root. You can put it on anything. You take some devices and you say, pull these devices together and give me a chunk of storage, and I'm going to do whatever the heck I want with that, and I'm going to carve it up however I want, and I can resize, move, take snapshots, all kinds of good stuff. And it's extremely useful for MySQL because you can freeze an instantaneous snapshot of your file system without copying all the data. All it does is it takes an atomic snapshot of the data, and then when you change some data in the original volume, it writes the differences to the area that you reserved for holding those differences. So you can apparently crash InnoDB, copy it away, restore it later. InnoDB will do its crash recovery, and then you'll have a nice backup. And you don't have to have 6.0 or commercial products or anything like that. Before LVM, you had to have a SAN pretty much to do those kinds of things. All right, so let me go back here.
Don't try it with pre-version 5.
And create a physical volume. Okay, I created a physical volume. That tells LVM, I want you to know about this volume. And then we're going to add that to a volume group. Okay? Oh, that worked. My God. That tells LVM this volume group belongs on this physical volume, or is associated with. I guess it's a little more complicated than belongs on. And then we'll create a logical volume, which now you can treat just like a hard drive that you plugged into your computer. There's an entry in dev now for that. So it looks just like any other SCSI drive or something like that, any block device. Which means that I can make a file system on it. Making a file system. Takes a little bit, probably fsync. And then I'll show you what I do for MySQL. What I do for MySQL when I'm going to store my MySQL data on an LVM volume is I make a directory called /data, and then I mount my new physical volume on data. Okay. Then I make a directory. Now, mind you, because this is now mounted, that directory went into the flash drive. It didn't go into /data on my hard drive, which is where I created /data. I'll go to var lib, which I have previously emptied out. I will now make a symbolic link to my new flash drive directory. Okay. And now I can start, let me move, I've moved away the contents of MySQL, so I'm going to move those things into, I could either move it into data MySQL, or I could move it into var lib MySQL, which is the standard place on most operating systems to install MySQL data files. Okay, so I've moved it there, and now I can start it up,
Let's see if this works. This is where things are untested. Probably a slow flash drive.
When you create the LVM 500 meg, how much is it actually how much is free with that?
It has allocated you've added that flash drive to your pool of storage. LVM is now tracking free space and use space on it. I don't know what it actually does on
How much
disk.
free, I guess.
Okay, failed.
Small over
I don't know why that failed, but I don't have
there. Look
got
at the
enough to
log.
log out. Nah, let's just forget it. Let's say if I had MySQL running there, just pretend that. I could, let me put this at the top of the screen. Let me show you what the LVM stuff looks like. So first of all, PVS shows you my physical volumes. VGS shows you my volume groups. LVS shows you the logical volumes. So you can see I've made a 500 megabyte logical volume there. So now I'm about to make a snapshot of, ooh, interesting. Yeah, I didn't start that either. A snapshot. And I gave it 10 megabytes, I think. Yeah, I said 10 megabytes, and it's rounding that up to 12 megabytes of space that it'll allocate for the snapshot if I modify the original volume. Let's look at LVS again. The screen is wrapping a little bit here, but if you didn't see it wrapping, you would see that the A snapshot, which is the first entry now, is a snapshot of demo LV, and it is, well, it's 0.1% used. I'm not sure why, because I haven't done any writes on the original volume. But this is what happens when you create a snapshot. Now you can make a directory. 12 seconds left. Make a directory. Oh no, I mistyped that, and I'm out of time. And you can mount the snapshot just like any other file system. All right, thank you. And for my next trick, okay, so let's talk about Cacti for a little bit. Ronald mentioned it. Cacti is an interface to RRD, which is a round-robin database that takes time series data and mushes it into a fixed size file. When you reach the end, it loops back around, and you can define aggregations. So as you keep shoving data in this end, it fills up maybe this much of it. Hold my hands up here. It fills up maybe this much of it with the stuff that's coming in, and then as it does it, it aggregates stuff into here. Let's say you're putting every 5 minutes in here. You can aggregate every day in here, and then you've got some more space over here that you can aggregate by the week, and then by the month, and by the year. So it's a really nice system that stores this data and does all sorts of things. Like if you send data but not at quite 5-minute intervals, it'll figure out, well, I'm supposed to interpolate these values, and then you can generate beautiful graphs from it. So a lot of the graphs you probably have seen are from RRD tool. Cacti is an interface to that. It's written in PHP. It has a poller which goes out to your machines that you have defined and runs a polling process against them, pulls back data, stuffs them into RRD files, and then gives you a pretty interface to graph against. Is that fast enough? Okay. That's the intro to Cacti. It's nice if it works well, but it can get nasty because it has sort of a strange data model, and it uses its own sort of unique identifiers that look like UIDs. And if you export a template, which is a sort of set of descriptions of graphs and how to get data and what to do with it, if you export it, it goes into an XML file, which is incredibly nasty, and then you can import it into another server, which is incredibly nasty if you've exported something that you've modified and the other person had also modified, and now you just, by importing, he overwrote his own settings or had some other conflicts, or all sorts of nasty things can happen there. Plus, it's just really hard to make templates. It's really, really kludgy. So a while back, I took the existing MySQL templates, which are now probably not the first result on Cacti MySQL templates from Google anymore. Probably mine are now, but I'm not sure. And I rewrote them to avoid a lot of the nasties, like not being able to import into certain versions of Cacti and stuff like that. And then I realized this is a pain in the butt. I'm going to write a generic framework for making Cacti templates. And I'm going to try and solve a lot of Cacti's problems. So let me see if this works. I'll show you some graphs, pretty pictures.
These templates, they're written in XML, are they?
Yeah, they're XML. And if you create them the traditional way, you do a lot of pointing and clicking inside of Cacti, waiting for pages to reload, stuff like that. So the MySQL templates are pretty detailed. I've graphed about everything I could think of in here. So this is sort of a sample of, actually this is live data from a customer system this morning. You can see there's a little blip. See that little white line down the line of the graphs? Some network problem that I haven't debugged yet. There's all sorts of like different types of selects and stuff like that. It's not looking real pretty here, but it's pretty, trust me. And there's a whole bunch of InnoDB graphing in there as well. And this is just the thumbnail view. One of the other things that I don't like about Cacti graphs is that if you actually want to see what the numbers on them represent, you have to add all of these numbers to the bottom. This is automated for you. So every item that's on there, you can see the numbers along the bottom if you click into it. So I solved a lot of problems like overuse of data storage on the hard disk and redundant polling that slows things down too much, etc. And then I went on and I said, let's build some systems for monitoring generic system stats in a better way without using SNMP. So everything is done over SSH, nothing to install. You can do this on an exposed system that you don't want SNMP or something else like that on. It can be bare bones because it's just done with Bash, essentially.
So you modified Cacti, not the templates?
No, I modified templates and I wrote new scripts to actually pull for data.
So you haven't actually modified it for Cacti install?
I haven't modified Cacti. There are too many people with Cacti that this wouldn't solve any problem for. I don't want to tell people to upgrade or to install patches. I just want to have a better set of templates for them. So here are some system statistics stuff that don't go through SNMP. And Apache, and Memcached, and Nginx, and anything else that our customers need. This is very customer driven. That's about it. Next are some harder things like, oh, I have a minute, so I can slow down. Okay, so I'm also building data queries, which are a powerful but even more complicated thing to do in Cacti, which will reach out to a system and say, show me what you have of some resource, like a disk, and then it's just point and click to create a graph for each disk. So some things like, this would lend itself well to, suppose I want to graph the activity or the resource usage of a particular process. I can look in PS and I can see, oh, there's MySQL, there's Apache, there's Nginx, there's Leidy, there's whatever. And so this is not done yet, but in the future I'll be able to say, go query, show me the top 5 CPU consumers. Those will show up in Cacti, click, click, click. Now you have a graph of the resource usage of each of those things. And I'm extending my meta framework to deal with that in a nice way as well. So anybody who wants to write a Cacti template, I encourage you to look at this. It makes it a lot easier.
Where are you putting it?
Oh, the most important part. MySQL Cacti templates .googlecode.com. It's on Google Code. That's all.
How often should you, LVM for example, do the snapshot?
How often should you do the snapshot?
Yeah.
Take a snapshot when you want to make a backup.
So you take a snapshot and then you have 10 meg to then, that can monitor the changes until the next snapshot? What if it runs out of space?
It can easily run out of space. I didn't go through how to calculate how much disk space is likely to be used, but we've actually written like 2 or 3 blog posts on MySQLperformanceblog.com about how to calculate how much space you're likely to need for the snapshot. And you can monitor how full that is with the LVS command. It shows you a percentage of fullness.
The other thing is that I didn't understand when I first started using it was that you really want to try to copy that snapshot to an actual other disk and then destroy it as quickly as possible, right?
Right. So what I didn't say was that a snapshot is not a backup. Snapshot is an easy way to copy and make a backup elsewhere. But you don't want to just say, snapshot, okay, I've got a backup. Then your disk crashes.
And then
right.
I wanted to also mention one other interesting use for LVM snapshot, and this is some sort of testing the live environment. Of course, backup is good, right? But let's say you want new MySQL version, and you want to ensure it doesn't screw up your data or something. You can just create a web snapshot and LVM. Two snapshots are reactable. So you can start a MySQL out there, and if it screws up, you can very quickly go back.
Right.
I, for example, have seen people trying to say, oh, is my replication is going to work if I upgrade to slave if I want? Just do it on snapshot, right? And if it fails in an hour, you can still throw it away, and you have your old MySQL stuff out there, which simply will catch up after you start. That's it.
We haven't benchmarked yet, but it's on the to-do benchmark and to-do blog about list to benchmark the impact, the overhead of running LVM versus on the raw file system. It seems to be pretty low, single-digit percentage certainly.
I did the benchmarks a long time ago, and this is,
It's just trivial.
Yeah.
And the benefits are so huge.
So what about the impact of doing a flush beforehand? Do you recommend you try to do that, or don't try to do it?
Of doing a flush?
Yeah,
Flush
flush
tables
tables
is
to get a read, like to get a read consistent view for InnoDB, or you don't care.
Oh, I don't care. So if your system is running all InnoDB, just take the snapshot. Flush tables with read lock doesn't do anything to InnoDB anyway. So just take the snapshot, let your server keep running. If you have any MyISAM tables, you may want to flush those individually before you take the snapshot. You always have some MyISAM tables in your MySQL database, but those are probably not really used.
And there is one more case when you want to do flush table with read log, if you do LVM backup from the slave, because you can get this position in the master binary log trivially by the binary log size. But if you have it on the slave and you want to know where it's on the master, you better do throw slave status.
Right.
After flush table with read log.
Yeah.
Is the snapshot kind of like an anti-delta? Or that's the one thing I've never quite understood. It's like you're taking a position on where it is, right? And then whatever that snapshot is how you would obtain the state of that data when it was snapshot?
The snapshot is an area which you can write the original version of blocks. So let's say my file system has 100 blocks. I take a snapshot and somebody changes block 5. Before that block gets written, original block 5 goes to the snapshot area. Now, when I'm reading from the snapshot, let's say I scan through all those blocks, 1, 2, 3, 4, I'm reading from the original file system, block 5, oh, that one's been changed, I'll go read it from the undo space, 6, 7, 8. So this way, the snapshot looks like the original file system without actually containing all of its contents. Something else to think about here, this didn't occur to me for a long, long time. If I change block 5 again, there is no further overhead. It's already been copied, there's no need to save it again. So in real-life use cases, such as InnoDB backups, there's the hot area of your data that gets changed, so you don't need to make your snapshot as big as you might think. For really large installations, 20 or 40 gig, I think the 40 gigs is the largest of the customers that I've worked on. We can copy off probably close to a terabyte of data before 40 gigs gets written.
The snapshot's writable, is that right?
The snapshot is writable.
Mount it.
You can mount it, you can write it, it looks just like any other file system. Yeah.
Where's the LVM configuration data stored?
It's been a long time since I've fooled with LVM configuration data, so I've forgotten. All right, so this is, I'm triple dipping now.
The post that you guys have, you got a performance blog post like 2 years ago, that stuff's still accurate?
Probably. I don't. Yeah.
And LVM2 was there for a while.
Yeah, it's been around for a while.
Question. So I guess what I was getting at is, if I had Ubuntu and the CentOS installation on my hard drive, would I be able to see an LVM if I share it on one device?
Probably not. I can't think of a way to, unless you're doing like a virtual machine or something.
You guys set up LVM on virtual, like Zen or VMware, like to test it? Is it pretty easy to do that?
Yeah.
Virtual?
I have a CentOS virtual machine and VirtualBox on this thing, and it's on LVM by default, actually.
When you did the install?
Yeah, when I did the install.
Another thing to point out is there's a nice backup script that lets Gremlin run
Yep,
it.
my LVM backup, and that's Percona uses that a lot.
Run it, because I noticed when I ran it on what I had at Grazer was I had a single disk where I did the snapshot. It was on the same disk, and if I ran that script just kill the performance on the live database. So what you want is an extra disk. Make the snapshot, mount it. This is what the script does, and then copy all the, mount the snapshot, copy that over to this disk. So that's essentially what you want to do as soon as possible, because the bigger it gets, the
Well, actually, the overhead tends to go down.
You see a spike as you initially write your transaction log in the hot part of your data, and then you're writing, a random block here and a random block there, but not tons of.
I mean, it's all depends there, but on the same side, copying from snapshots, it starts to cause more I/O because more pages go.
I think what was killing me was copying the mounted snapshot, the actual SCP or whatever.
Okay, well, you can see where it says, like for example, we have patches for tar, like called slow tar, for example, to space it around so it doesn't saturate the I/O copies.
A recent blog post called "Living with Backups."
You can
talks about all
rsync, you
those
can
tricks.
slide in rsync.
I'll have to check that out.
rsync, you can limit the throughput.
Yes, you can do rsync if you are doing it over network. To nothing, right? If you try to do incremental backup and you do it to the live copy, then chances are your bandwidth requirements will go pretty small.
Sure. No, but if you use rsync as the dump
Yeah.
copy, you can limit rsync and turn off compression and blow away what you're rsync.
Yeah, well,
Should
the
use that
thing-
instead of tar.
and another thing I want to mention about the tools here is MMM, which might call master. It also has like built-in stuff to do LVM-based clones from master to a slave. So that's all, and backup. So that's also quite handy.
I think lightning talks are over now.